Okay, let's take a look at composition of functions. Compositions of functions takes two functions and combine them. So if you think about transferring money, you might convert to Canadian currency and then convert over to euros from American dollars. But this gives us a rule to go right from American dollars to Canadian currency without having to go, or to euros without having to go through the Canadian function first. So what we're going to look at first is a composition called f of g of x. And what it literally means is take the function f and fill the entire g of x in where you see the x. So we're going to take the entire g of x function and fill it in where we see the x in the f function. We always deal with the outer function first, and then the inner function is what we fill in for x. So I'm going to take the f function, and where I see the x, I'm going to fill in the g. So that's the g, and it's going to go right in where I saw that x. Now I can do a little bit of simplifying. Remember that a cubed and a cubed root will cancel each other out, and I'm left with x minus 5 minus 27, or x minus 32, if we do some combining alike terms. So we would say that f of g of x is equal to x minus 32. Now I know when you're typing out your essay work, you don't have this little kind of squished o to use as a symbol, so a lowercase o is perfectly fine. When we look at our next one down, the g of f of x, we're going to look at the outer function is what we're going to evaluate, and we're going to fill the whole f function in for x. So in the g function, where we see the x, we're going to fill in the f function, or the x cubed minus 27, and then we have the minus 5. Now we can combine these like terms. And I'd like you to remember that in this case, the cubed and the cubed root don't cancel out, because the cubed is only attached to some of what is in the cubed root, not all of it, and we can't actually simplify this anymore. You do want to be out on the lookout for things you can simplify. So if I were to look at something like the cubed root, I'm just going to give you an example of something you could simplify, of x cubed minus 8. Well, that could be written as the cubed root of x minus 2 cubed, and that would simplify as the cubed and the cubed roots canceling out. But these ones actually won't simplify because it's only attached to part of it. So you do have to be on the lookout for things you can simplify, but in our case, our actual solution won't simplify, so we're going to leave that as x cubed minus 32, the cubed root of all of that.